In this video, we will be looking at some more application and some more examples of the ideas that we discussed in section 3-3. Now, I'd recommend that you first watch the 3-3 video and then you watch this one where I go through some more examples of the ideas that are in section 3-3. So this first example is which lines are parallel if angle 1 is congruent to angle 2? So if angle 1 and 2 are congruent, then which lines are parallel? Well, the line that connects 1 and 2 must be the transversal. So here's the transversal, which means that line A and line B must be the two lines that we would then know are parallel. So it'd be lines A is parallel to line B, and that would be by the converse of the corresponding angles postulate. All right, determining whether lines are parallel. The fence gate at right is made up of pieces of wood arranged in various directions. Suppose angle 1 and 2 are congruent. Are lines R and S parallel? So angle 1 is here and angle 2 is here. So if those are congruent, then R and S would be parallel. And the reason is by the converse of the alternate exterior angles theorem. All right, some more algebra questions. Determine the value of x for which lines R and S would be parallel. Then find the measure of each labeled angle. So in order for R and S to be parallel, then these two angles, the alternate exterior angles, must be congruent. So 2x plus 6 would have to be equal to 42. Okay, so to solve this, I would first subtract 6 from both sides, and 2x is equal to 36. And then I would divide both sides by 2, and x is equal to 18. Okay. Now the question asks to then find the measure of each labeled angle. Well, this angle is still 42, and this angle up here would be 2 times 18 plus 6, which would also be equal to 42. Okay, in number 2, this angle, 98, and this angle are same side interior angles. Now they're not congruent, although they look similar. They would have to be supplementary for R and S to be parallel by the converse of the same side interior angles theorem. Now, to be supplementary, they must add to be 180 degrees. So 98 plus 3x minus 17 would be equal to 180. Okay, so I solve this equation. I get rid of my parentheses. 98 plus 3x minus 17 is equal to 180. Now, I will combine like terms. And I get 81 plus 3x is equal to 180. And then I would, let's see here, subtract 81 from both sides. I have 3x is equal to 99. Divide both sides by 3, and I get x is equal to 33. Okay, I still need to plug things back in. And 3 times 33 minus 17 is 82. Okay, and 82 plus 98 is equal to 180. All right, a few more. These two angles, now it's kind of hard to tell from the picture, but it means this angle in here. These two angles would have to be supplementary for R and S to be parallel by the converse of the same side interior angles theorem. So to add to be 180, I would take 2x plus 20 plus 6x plus 24 is equal to 180. So I remove the parentheses. 2x plus 20 plus 6x plus 24 is equal to 180. Combine like terms, 2x plus 6x is 8x, and 20 plus 24 is 44 is equal to 180. Okay, so I subtract 44 from both sides, and 8x is equal to 136, and divide both sides by 8, and x is equal to 17. Okay, and that's x. You plug it back in. So 2 times 17 plus 20 is 54 degrees. And let's see here, 6 times 17 plus 24 is 126. Okay, and 54 and 126 do add to be 126. Okay, I think you get the idea. I'll just set up the next one, but I won't solve it. For R and S to be parallel, these two angles, the alternate exterior angles would have to be congruent. So 3x minus 63 would have to be equal to 2x plus 2. And you can solve that and plug the numbers back in. Okay, let's look at two proofs. One is proving the angle 1 and 7 are congruent. Okay, I changed my mind. We'll be looking at one more proof, just so it's a little bit different than the ones that I talked about in the previous video. Angles 1 and 3 are supplementary, and we want to prove that A and B are parallel. Okay. Now keep in mind that we can't use any of our postulate or our theorems that rely on things being parallel, because we don't know that yet. Okay. But what we do know is what we're given is that 1 and 3 are supplementary. Okay. And we also know something about 1 and 2. Okay. 1 and 2 are also supplementary because they're a linear pair. Okay, so we have two options of how to go about proving this. One option is, if you remember way back in chapter 1, we talked about a theorem that was the congruent supplements theorem. Okay, where if two angles are supplementary to the same angle, then those two angles are congruent. Okay, that's exactly what the situation we have here. Okay, now if you don't remember the congruent supplements theorem, then you could use some algebra. Right, what supplementary means is that two angles add to be 180, and you do some algebra, and you can get that angles 2 and 3 are congruent. Okay, now I'm going to go with the congruent supplements theorem, because it's easier, but you could prove it either with that theorem or using a lot of algebra. Okay, our first statement is the given. Angle 1 and angle 3 are supplementary. And the reason is it's given. Okay, the next statement is about angles 1 and 2. Angle 1 and angle 2 are supplementary. Okay, and the reason for that is the linear pair theorem. Okay, now that theorem back in chapter 1 about the congruent supplements theorem, since 3 and 1 are supplementary and 2 and 1 are supplementary, then that means that angle 3 would have to be congruent to angle 2. And that's by the congruent supplements theorem. Okay, any theorem with a name is worth remembering. Okay, now if 3 and 2 are congruent, then I would know that A is parallel to B by the converse of the corresponding angles postulate. Okay, so here's the proof of proving that A and B are parallel when we know something about angles being supplementary. Okay, so I hope that helped clarify and help you understand the ideas that are covered in section 3-3.